This is just to say, it's kind of fun, this is as I said, this is kind of a bit of an odd collection of things. So there isn't, one set of tools that tells you you're in complex systems or whatever, but it's basically all of the modern things of science, right? So differential equations, I realize, work more for continuum things, but they're still obviously very important. We need lots of things for descriptions these days. There's a lot of statistical techniques, lots of models that are stochastic in some way. There are really fundamental pieces coming from StatMech, and we'll show some of those in a little bit. Oh, and the black box issues of machine learning. So there's a great lure right now that we can seemingly do everything, but we can't understand. Of course, we can't understand anything, and so a lot of people don't really care about that, right? So anyway, so computer modeling, and I've talked about this gap between these sort of toy models that are well-defined and easy to understand, but have really interesting behaviors and tell you things that you certainly couldn't intuit just by thinking. You have to simulate them. And then everything, you model everything. All right. We'll have this soon. This was the gigantic, I think this was really, the big change was getting enough data about systems, to be honest. Many kinds of systems, but eventually getting enough, and involving people, right? Systems that involve people. That was got a lot more people excited. And the thing is, there are networks under many of these systems, and that opened up tremendous amount of work of all kinds, really. But the driver is data.